The reason why I selected this one, it's like 1 or 2 in your lab manual to do. You notice there's 1 reactant, but yet there's 2 products. Well, here's the trick. I did it the change method. Let's see if I did it the half reaction method too. No, I did. Okay, I did it the change method. All I did, here's the trick. Just write it twice. Okay? You connect this one to one of the ions and this one to the other ion. You figure out that this iodine here went up by 5, but there's 2 doing it. So that's an up of 10. That means oxidation. That means the iodine going to iodate is the reductant. Whenever you have 1 reactant, you've got to mention, when we ask you reductant or oxidant, you've got to mention what it goes to. Okay, the other iodine goes to iodide. It went down by 1, but there were 2 doing it. So that's a down of 2. I didn't cross multiply. I just knew that if I multiplied this one by 5, here, I've got it on this next paper. Can I move this paper down? I mean, get the other sheet, because then I show you my work. Are we good? Okay, here, I'm going to put this down. This is what I did. See, 10 times 1, I didn't show times 1, equals 2 times 5. So the 1 goes here, and the 5 goes here. So now I have 6. See, that just helped me see which one goes to what. You balance, if you had a 1 here, but you've got a 2, you put a 2 there. If you've got 10, 5 times 2 is 10, you'd put a 10 there. Now my charges are neutral here, but negative 12 here. So that's going to tell me I'm going to need 12 H pluses. Or if you don't want to do it charge way, however many oxygens you have here is how many waters you're going to have here. So I've got it right here. And this particular reaction, you could, because they're all divisible by 2, you could reduce. I didn't reduce it, but I mean, and in your lab manual, that's up to your lab instructor if they're going to be picky or not. When I grade these, I just simply write by it, you could have reduced, but I don't take off. Okay, so let me say something again. The reason why I selected this problem is because in your lab problem set for redox, you've got a couple of them where it just has 1 reactant. The trick is just write it twice. Did y'all follow that?
Yeah.
Okay. Now, we are going to do the half reaction method. What the half reaction method does or says, you have a reaction, and this is similar to one of them in your lab manual. You, instead of figuring out oxidation numbers, you just connect links, the common element. Y'all see how I looked at my overall reaction here, granted it's not balanced, and I just connected the links. Now, you always make sure the link or the common symbol is balanced. What I'm saying there, had this been an Mn2O4, that Mn little 2, I'd have to put a big 2 there. But there's just 1 here and 1 there, done. Okay, that one's done. Here, Br minus, Br2, leave it alone for right now. Okay, so you connect the links. Now I'm going to my next page where it's showing the work. Because the link here, manganese and manganese, is balanced, but I don't have any oxygens here, you use water. So if I have 4 oxygens here, I'm going to add 4 waters. Now I just messed it up. Mn's happy, O is happy, but I've got 8 hydrogens. So you come back over here and add 8 hydrogens. meaning hydrogen plus. The last thing is you got to look at your charges. My charges here don't balance. This side does not equal this side. So you're allowed to use your electrons in this, it's called half reaction method or ion electron method. You're yet allowed to use your electrons to help you balance charge. So here's, okay, this was the second sheet. I've done this in steps. Here we go. I noticed the charge here, okay, and I noticed the charge there. It looks like I'm going to need to make this come down by adding 5 negatives so that my charges match on both sides. Could y'all follow that? Because I'm gaining electrons here, this is reduction, so the permanganate is the oxidant. Okay, I've got that. I did half of it, right? I did the permanganate part, but I haven't done the bromide part. Okay, I'm putting my sheet down, and now I'm going to do the bromide part. Okay, you go ahead and balance atomically. Okay, and then you notice, oh my goodness, I have no oxygens or hydrogens deficient, so no water's needed. But I have 2 negatives here, and this is neutral. I need to add electrons here to make it 2 negative. Because I'm losing electrons, that's oxidation, so the bromide becomes my reductant. Okay, last step. You write your 2 half reactions, forget these numbers right now. You write your 2 half reactions, which you've just balanced. Your electrons, the 5 electrons here and the 2 electrons there, they have to go away. So you cross multiply. And then you distribute. And then you add it up. Your 10 electrons will cancel on both sides. And then you have your answer. I think, no, this one cannot be reduced because of this 5. You can check charge at the end, which they're both +4s. So I know I did it correctly. Now I've got another one to do. You could check your work. You could go back and do this one. Maybe I did do it, the change. This is so similar. Oh, if not, it's the same one as what whoever asked me to do off my sheet. Did y'all realize that? You know, the one I did earlier with the permanganate and the bromide? That was the change method. And I got the same answer doing it the half reaction method. Okay, example number 2. I'm picking this one for a reason, because it's the most commonly missed one on test. Here's my reaction. But I don't have my H pluses in it or my waters. But I'm going to tell you it's an acidic solution. So that means I can add water to help out the oxygens down the road and H pluses to balance charge down the road or to balance the hydrogens in the water. So I connect my links. This is just the first one, okay? So it's dichromate 2- going to chromium 3+. That's my link. I have to, the number one thing you have to do in this half reaction method, always make sure your links are balanced atomically. So I just did. And then I notice, you know, forget that right now. I notice, oh goodness, I have 7 oxygens on the left, no oxygens on the right, no problem, add 7 waters. Now that I've added 7 waters to make the oxygen happy, I've got to add 14 H pluses to this side. I check my charge, 12 and 6. I'm going to need to add electrons on this side to get the 12 to come down to 6. They have to be 6+, 6+. Okay, so this is because I'm gaining electrons here, it's reduction. So the dichromate is the oxidant. All this work was for that 1/2 reaction. Okay, I'm going to go to the second part of the reaction, which is the other half reaction. Oops, sorry. It's the iron 2 going to iron 3. No oxygens. So I don't have to worry with water. I'm just using my electron to balance the charge. I notice that I'm losing the electron. It's on the right side. So that's oxidation. Therefore, the iron 2 is the reductant. I cross multiply. There were 6 electrons in the other one and 1 here. So I'm cross multiplying. Distribute through. My electron, the whole reason why you're cross multiplying here, you want to get your electrons out of the overall reaction. You will never have, in an overall balanced redox reaction, the presence of any electrons. And so this is my final answer. I check charge, sure enough, it's matching. Questions with that? Are we good? Okay. One more example of this type, but we're going to balance it in basic solution. Mallory, you're frozen on my screen. Well, you were. Now you're not. It's okay. Okay, guys. This is not how I normally would teach it. I feel the way that I would normally teach it with the basic solution is better, but because you have the book that's doing examples, if it says in basic solution, just balance it using the rules for acidic solution, and then I'll show you what you do at the very end. Okay, so here, and I hate that I'm doing this, and I'm going to go ahead and say why. I've got this reaction where zinc metal is with this nitrate ion. The zinc is going to be oxidized. That you don't need to know that, but 0 to 2 up, it's oxidized, forming nitrogen oxide. Now, here's why I hate teaching you guys to do it in acidic and then change it over to basic. This is an acid. This is an acid. So we're going to go ahead and treat it, you know, just like I finished doing. Connect your links. Okay. Balance atomically, zinc and zinc, 1 and 1. Add your 2 electrons here because this is loss of electrons. This zinc metal is undergoing oxidation, therefore it's the reductant. Great. Nitrate to NO. NN, that's balance atomically. Okay, I have 3 oxygens here and only 1 here. This side is missing 2 oxygens. Add 2 waters. Now I've got 4 hydrogen ions. Put it over here. Neutral, -1, 4 positive. I need 3 electrons to make it neutral. Reduction, electrons are here on the left side. That means the nitrate ion is the oxidant. Okay, now on this, okay, so what do we do? Well, we're going to cross multiply. We're going to cross multiply, cross multiply my 2 half reactions, distribute. The whole reason we're doing that is to get rid of the electrons. I notice all of this, the charges balance, but wait, they don't want it in acidic solution. They want it, or my example here, they want it in basic solution. No worries. Every time you see an H plus, add an OH minus to it. So look what I did. Oh, whatever you do to one side, you have to do to the other side. So guess what 8 hydrogen ions and 8 hydroxide ions make? 8 waters. And if I have 8 waters here, and I cannot read that, is that 4 waters? I'm going to subtract water from both sides, the lesser of the two, and you get your overall answer. Where in acidic solution, the hydrogen ions were on this side, but now in basic solution, they're on this side. No big deal. Now, the reason why, and Dr. Burns, most of my colleagues teach it this way because the students are just learning the little rule. If you have an oxygen deficient side, add water, and then counter that with your H pluses. Now you can do it for both. You just have to do that basic solution step at the end. Now, all that, 3 or 4 sheets to go over that. When in one sheet, well, almost one sheet, I could have done this by the change method. Ta-da! This is the change method. No, instead of doing half reaction links, you're connecting the links, aren't you? You figure out the zinc goes up by 2 and the nitrogen drops by 3. You do your little cross multiplying to get the coefficients on this side. You then balance. If there's 3 zinc here, there better be, here, I did it here, 3 zinc there, etc. Okay? And we're almost done. See, this change method is the way to go.
In the change method,
I'm sorry, what?
In the change method, when there's like multiples of, like, say it's a C3H8,
Yes.
can you explain why we multiply them?
Sure. Let me, here, that's a good one to do. I think I'm following you. Let's do C3H8 to CO2. Is that okay?
Yeah.
So let me just write. So this is just a half one. I mean, I'm going to write it as the change method though. So let's see. That's a plus 8. So this has to be minus 8/3. Well, or minus 8, yeah, divided by 3. So minus 8/3. Oh, this is going to be fun. Okay. Can y'all see that? This one's easy to do, right? The CO2. Okay. If hydrogen 99% of the time is a +1, the only time hydrogen is a -1 is with an active metal. So if this is a +8, this half of the compound has to be a -8, but there's 3 of them sharing that. No problems. If this is -8/3 and I change my 4 to +12/3, can y'all see that? Sorry. So it goes from -8, climbs up to 12. That's an increase of 20/3, but there's 3 carbons doing it. So that's going to be an increase of 20. So
on which side is there 3 sides to it, like 3 carbons? I just don't get the multiply by 3.
Oh, okay. We'll come, oh, where's my Kleenex? Sorry. We'll come back to this one. Oh, no, or maybe I'll just do another organic, and then maybe you'll see a pattern. Again, this is just part of the reaction. Okay, do we agree that this one here, if this is a +10, this part here has to be a -10? But there's 4 of them. So you're doing a change for each carbon. So this would be a -2.5. So when I connected that, I would have said up by 6.5, but there were 4 carbons. So that's up by 26.
But then, okay. And then that evens out when you balance.
Yeah,
after?
yeah. That's why you do it. If you didn't do that, it wouldn't even out. You'd get wacko coefficients.
Okay.
Matter of fact, I think I can maybe squeeze in here. We'll just finish this one out. Sorry. Okay, this is now my entire. Okay, so this is a combustion reaction. So I know carbon changed. Why? It's with hydrogen on the left, but it's with oxygen on the right. So carbon is a link, or it changed. Oxygen goes from 0 to a -2. So if I write my little line up here, that goes down by 2, but there's 2 oxygens doing it. That's down by 4. So I've got oxygen being reduced. It's the oxidant. And this is butane, but the organic being oxidized, it's the reductant. Now, I could cross multiply. You could multiply this by 26 and the 26 by 4, and then you would definitely have to reduce. Or I could figure out, if I multiply the 26 by 2, that's 52, and 4 by 13, that's 52. So my 13 is the coefficient for oxygen, and my 2 is the coefficient. So let me just finish it out. So we've got 20. So last check would be, if I've got 26 here, oops, that's not right. What did I do wrong? 4 times 13 is 52, 26 times 2. So 2, 13, 8. Oh, that's a 10. Stephanie here can't. Okay, sorry. So it's 2, 13, 8, and 10. So if I have 26 oxygens on the left, 16 plus 10, I have 26 on the right. See what it did? This, by doing this little step, you clear those decimal numbers. Does that make sense?
Yeah.
Okay. Yeah, you probably have an organic-y thing on your lab problem set. Okay, let's see where, oh, back to my zinc problem. Or maybe I already finished it. Oh, okay, sorry. When you do it the change method, you did the cross multiplying here, so you have the coefficients on the left side. You're just following where your line is. If you've got a 3 here, then you need to balance that. If you've got a, whatever this number is, 2 here, you've got to balance that. Oh, I guess okay, it's on this next paper. So here, I balanced it. 3, 2, 3, 2. But we have a problem. The problem is I've got 2 negatives here. And how many positives is that? 6 positives? I need to add 8 hydroxides here to get it to come to match that. And then once I add the 8 hydroxides, I'm going to add the 4 waters. So I just did the change method on the same reaction that I spent 4 sheets on the half reaction method. You guys just pick a method that you're comfortable with doing and just do them that way. However, I will say, in your lab problem set, there's 5 pages of 5 each. We specify at the top of that, you must do this page in change method. You must do this page in half reaction method. So you have to obey that. The reason why we did that is we want the students to get comfortable with one or the other method, because had I been giving you a test, I would say, I don't care what method you use, just get it done. And what if we were taking an actual test, and Mallory can remember this, the last test, what I typically do is I give, for 40 points out of 100, I give the student, I don't remember, Mallory, 6 or 8 of them, and I say, hey, you can do 1 for 40, 2 for 20 each, 4 for 10 each. I don't care. It's a gamble on your part. A lot of times the students would do either 1 for 40 because they were certain how, that one was right, or some of them would do 2 for 20 each. Well, that's not how I can do it this semester. I wish I could, but I can't. Now, I'm almost finished. Almost. I am going to, sometime this afternoon, look on CHEM 101. I know that's your favorite platform. It's mine too. I'm being sarcastic. And I'm going to pick maybe at least 5 redox things for y'all to do, only because I'm pretty certain you're going to be able to balance them. But I want y'all to, I don't know how, I don't know if it's a drag and drop thing on how if you have to write the physical states, or how you write the superscript or the subscript. So you need to practice it. Does that make sense what I'm saying?
Yeah.
Okay. I'm going to look for something on CHEM 101 that's a practice. And I will email that out like, hey guys, go to your CHEM 101 and find, we'll call it quiz. No, it'll be under quizzes. It'll be, or no, I don't know what it's under. It'll just be called practice redox balancing, something like that. Okay. Last thing. And I have to go over this because it's part of your activity to be able to do the very, very last part of the activity that I've posted on the assignments folder. Okay, this is called redox titration. Now, let's just jump to here for a minute. Vn equal Vn. Do you guys remember when you had an acid, what you had to multiply the molarity by to get the normality? Anybody?
The charges of the cation.
Or the number of hydrogens, right? Y'all remember that?
Yeah.
Y'all remember that? Well, this time, to get the normality, you multiply by the change. The change. So here's my problem. It's a made-up problem. If I have a volume of 0.100 molar of this dichromate ion or solution, and I have a different volume, but I don't know the concentration here of this manganese solution, I would simply, to use this formula, I would take my 0.100 molar here, multiply by 6, that's the equivalence per mole, to get my new normality. So look, V times N equal V times, we're going to solve for N. Now, but what if the question said, well, we don't want the normality of that. We want it in molarity. The reason why they ask you that way is they're trying to trick the student to use Vm equal Vm. You've got to convert to normality and then convert back to molarity. Well, how do I do that? If I know the normality of this manganese 2 and I see that it changed by 5, this is what I'm going to do. I'm going to take the normality to cancel my equivalence. I'm going to divide by the change of 5, right? And I've got my molarity. That's called a redox titration problem. Now, did you notice something? I didn't even have to balance the reaction to do this trick. I didn't have to balance it. But if you do go to the trouble of balancing it, because you're going to cross multiply and get, and add your hydrogens and your waters, whatever, you could keep it in molarity, use your mole ratio, if you will, and solve for the molarity that way. But you know what? My method of converting to normality is a time saver. Now, I don't know what your final exam is going to look like. It's not going to be the typical one we give because we're not allowed to give a true ACS exam online. But 2 of those questions were like what I just went over. And if the student just converted the molarity to normality and then back, they had the answer in like, I don't know, 15 seconds. Versus if a student did all this work, you know, that's like what, 5-10 minutes later. Are y'all following what I'm trying to say? Okay, what I am going to do, and I have this on my list of stuff to send you. Maybe they have some redox titration problems on Chem 101. I don't know. I haven't even looked at it yet. But I'm going to pull up an old practice that we would have done, say, on a Saturday. I'm going to delete some of it, but I want you to at least practice what's called a redox titration problem. Before I email it, I'm going to work it so I can type in the blank what the answer should be. So if you're doing it, you can check your work, okay? Questions? Anybody? I went over the notes that I was going to do. Any kind of questions with balancing? There is a, oh, let's see if I have it. Well, I'm going to go ahead and do this one because it trips up students. It's from your lab manual, but, you know, just don't tell your lab instructor I did one of them. It's fine with me. Okay. Let me write it on a piece of paper, bigger, without the work, and then I'm going to tell you why students get tripped up with this one. Okay, hold on. We're not going to, I won't do the whole thing. I'm just going to show you the trick. I ran out of room, sorry, but it's okay. Okay. This is cadmium sulfide, nitric acid, forms cadmium nitrate, sulfur, nitrogen oxide, and water. Okay, there is it's not a problem. Sulfur's mentioned what here, it's a -2, it's an element here, so you know that changed. The problem, nitrogen is mentioned 2 different spots over here. That means this nitrate doesn't change here, but the nitrogen of +5 does change there. So now I'm going to connect. I'm going to do this the change method because I think this is the type problem in your lab manual. So the sulfur went up by 2, and I'm going to connect the nitrogen. Sorry, this is going to be a mess. So that's a 2 and a 5. So down by 3. Okay. Notice I connected, obviously, the sulfur, because that's a free element here. That's a suspicious or suspect thing. And then I connected this nitrogen not to here, because it's still a 5, +5. I connected it to here. So this one goes up by 2, this one goes down by 3. Could y'all follow that? So I cross multiply. So now I'm going to cross multiply. And I'm going to write the numbers bigger so you can see where they went or where they're going. Now, okay. So I cross multiply 3 and 2, 3 here, 2 here. I follow my line. Okay. Oh, did I not? Oh, I didn't write the 3, sorry. Okay, I follow my line. You could go ahead and put I didn't mean to do that one yet, but it's okay. It's still got to be 3 cadmiums. So I follow my line and put a 3 in front of the sulfur. And there's 2 nitrogen here. I put a 2 there because that was my line. Then when you put the 3 here to balance atomically the cadmium, what happens to this 2? You've got to what's called update it by the other, well, how many more of these? 6 you have? 3 times 2 nitrogens. So what the student would have to do is update that by the 6 that are not changing. So the coefficient now for nitric acid is an 8. Once you get the coefficient for your hydrogens, you can figure out your water. So if I've got 8 hydrogens here, not 2, not 6, but a total of 8 now, then I'm going to need a 4 for the water. That's called having to update one of the things changing because it's connected to something that's not changing. Could y'all follow what I just did there? You still do my pattern of cross multiply, you know, figuring out the oxidation number, cross multiplying. They become the coefficients here. They also become the coefficients of the things changing. Then you start, when you start to balance atomically, you notice, uh-oh, I'm going to have to add more nitrogens there. Could y'all follow what I was trying to do there?
Yeah.
That is like number,
So that's where you got the plus 6 from?
I'm sorry, that's where I got the what? Say it again.
The plus 6 is from the nitrogens to balance the nitrogens.
Yes, here. Because
Okay.
3, yeah, 3 times 2 is 6 nitrogens there.
Okay.
Okay. I'm just trying to, as I glance through, that's like, oh, it's like 2 of them. It's like on page 79 of your lab problem set you're working on, number 4. It's almost identical to number 4. Okay, I mean, can y'all think of any other questions or?
How you earlier did on the electron method where you just added another product of the same one, does that apply to the change method also?
No, you, well, you can, yes. But I think
if you only have one product, you have to do that, right?
Right, but if they say it's an acidic solution, then you're adding H pluses and waters, okay? If they're saying you're in basic solution and you're doing it the change method, just add the OH minuses to help your oxygen or your charge. Or you could go ahead and do the H plus and water again, and then you have to do that last step.
What if it doesn't say it's in any solution?
Oh, then you could do it in anything you want. If it doesn't, oh, wait, no, I'm glad you mentioned that. Okay, we're going to do 2. I'm going to ask the class. Let me just make up, gosh, these are hard to make up. Let me find a page where it's, okay, here's one. Oops. Oh, that's my dog, sorry. I'm going to write 2 reactions down, and then I'm going to ask the class, which solution do you think I should use? Okay, here's my first reaction. It's like one of them in your lab manual. And let's say I don't tell you use acid or base. Let's say I don't. Can you guess which one you're going to use? Come on. Which one do you think you'd use?
The acid.
Yeah, you would use acid because there's an acid in the formula or in the reaction. Okay, here's another one. One more. I'm getting all my papers out of order, but that's okay. Okay, here's a good one.
Just to review, isn't the nitrate ion a base?
No.
Wouldn't it grab an H?
Oh, they've already done the net ionic.
Okay.
It's coming from a strong acid, HNO3, so it's going to be piddly.
Okay.
Remember?
But by itself, it theoretically would be a.
Oh yeah, it could be a conjugate base, but no, they've already, when they give you charges like this, guys, they're giving you the net ionic. Okay, no, wait. Oops. All I'm going to do is ask a question. Okay. Guess which solution you would use to balance this. Basic. But, I mean, I definitely would use basic. But if you want to connect, if you're doing it the ion electron method, you can use your H pluses and H2Os. And then at the very, very, very end, let's say I'm making up a number, you have 7 H pluses. Then you simply add 7 OH minuses to both sides. Does that make sense? So now you've got 7 waters on one side and 7 hydroxides on the other side. Are y'all following what I'm trying to say? What I would do, what are y'all doing in lab this week?
Radiation.
Yeah, the radiation of
Oh,
potassium
okay.
40.
Yeah. So that's just mainly it's a calculation. I would start working on this redox problem set. I would, pick a method and do those pages that say that method and for repetition. And then I definitely would start working on it, because y'all told me, or I think you said that it's going to be collected to, I don't know how in the heck they're going to grade it in enough time. I don't know what they're going to do. I'm glad I'm not teaching lab this semester. Okay, any other questions?
So I don't know if you can help us with the lab manual stuff, but number 2 on the first page of Redox was what I was wondering about, where there's the ammonium dichromate.
Yeah, I can help you on that, because it's really, once I give you the little hint, hold on, let me get it. Okay, yeah, I'm going to write it down. I'm not going to do it for you, but I'll give you the hint. Okay. So they want this to change method, which is, I definitely would have done it. It'd be very, very hard to do this one, the half reaction method. In order to do it the half reaction or the ion electron method, you'd have to write the net ionic of that. And I don't think y'all, that's another added step. Okay, here's the problem you're referring to. One reactant. You could write it twice and then connect the nitrogen to nitrogen and the chromium to chromium. Now, how did I know nitrogen changes and chromium changes? The big thing is nitrogen is an element on the right side. So you got to connect nitrogen. Chromium starts the compound here, but it's in the middle here. Because this is a long enough kind of compound, all you'd have to do is just connect and figure out the oxidation numbers. It's not, this is actually an easy one.
Well, I guess you probably would get the same coefficients then, but if you don't?
If you don't, then it would be better to write it separately.
Okay.
In other words, I think what you're asking is, what if you have to cross multiply and you get 2 different numbers? Then rewrite the problem where you have 2 of the reactants.
Yeah, okay.
Okay, yeah. Well, I was going to give you it's easy. Just do it, you'll see. Okay, another question. My goal or plan is to send a little quick practice with at least 1 redox titration. Do y'all want me to send more balancing redox? Because you got 25 in the lab manual. But I can. How about I send 3 redox balancing, maybe, and I'll say easy, medium difficulty, tricky. And then 1 redox titration problem. But I'm also wanting to send my notes for electrolysis and Faraday's law, because that's going to be my lecture on Friday. And oh yeah, and I'm going to go to Chem 101. Yay. And create a practice. Not a long one, just so y'all can practice. Mainly it's so y'all can practice. I haven't even looked at it. I mean, I'm assuming it's going to be drag and drop, because if you're having to figure out the coefficients, I don't know. I haven't looked at it yet. Questions? I think I've got everybody, but could you tell me if you came in a little bit late so I can just make sure I checked your name off? We're going to go through another, I have to report attendance. Oh wait, Julie, you're here, right?
Yes.
Here. Well, here. Jesse, are you here? Cassie? Laura? Sophia? Okay. Sophia, you're here? Oh, no. Sophie, you're here, but Sophia. Is Sophia here too? Sorry, I have two. Okay. Anybody else have a question? These were good questions. I hope that I'm trying to do the best I can with these, pieces of paper. I'm almost out of paper. It's okay. I'll get some paper somehow. Okay, well, we're gonna stop the recording, Mallory. Thank you. Or whoever recorded. Felicia.